So we have this question here, and it says a particle P is projected with speed u at an angle alpha above the horizontal from a point O on a horizontal plane and moves freely under gravity. The horizontal and vertical displacements of P from O at a subsequent time t are denoted by x and y respectively. So on part A, they say, derive the equation of the trajectory of P in the form y is equal to x tan alpha minus gx squared over 2u squared of sec squared alpha. All right. So in this particular case, we have a horizontal plane, okay, or horizontal ground, and a particle that's been projected with a speed u from what they say. So it's been projected maybe like this, and it's at an angle alpha above the horizontal, according to what they say. And we have been told that it's from a point O, and the particle will move freely under gravity. If we are going to consider the horizontal components against the vertical components, okay, so these are the two things we need to consider. All right, so for the horizontal components, the initial speed is u cos alpha. We know that acceleration is zero vertically, and the distance traveled after time t is going to be calculated u cos alpha times t. So what we're using here is the fact that s is equal to ut plus half at squared, but a is zero. So that's basically how it is. So u is u cos alpha and t is the time. So basically we are saying that x is equal to ut cos alpha, right? For the vertical components, the initial speed is uy. That's u sine alpha. The acceleration is minus g. And we can also consider the distance traveled. Okay, so here we can consider s being equal to ut plus half a t squared. So essentially, s is the vertical displacement, which is y. Okay, so we're going to say y is equal to ut, which is going to be ut sine alpha. And for half a, that's going to be minus half g of t squared. All right. So we now have the horizontal and vertical displacements of the particle after time t. All right. So I'll call this 1 and I'll call this 2. So if we take 2 goes y is equal to ut sine alpha minus half gt squared. And from 1, we can say from x being equal to ut cos alpha, we can deduce that t is equal to x over u cos alpha. So we're going to substitute that into equation 1. So therefore we can say, actually we can substitute equation 2 into equation 1. So basically that's going to be y is equal to u sine alpha times t. So that's of x over u cos alpha. And that's minus half g of t squared, which is x squared. Actually, that's x over u cos alpha squared. Now, this will simplify to y being equal to, and here the u's will cancel, and sine alpha over cos alpha is tan alpha. So we have x tan alpha, and on this part, we will be having, all right, on top, that's minus gx squared, and that's over 2 of u squared cos squared alpha. However, 1 over cos squared alpha is actually the same as sec squared alpha. So sec squared alpha here. So this is actually what they want us to derive, right? So that's how we do it. Okay, that's the answer here. Let's move on to part B. Part B says the greatest height of P above the plane is denoted by h. When P is at a height 3/4 of h, it has traveled a horizontal distance d. So they say, given that tan alpha is equal to 2, find in terms of h the two possible values of d. All right. Okay, so there are two things that we need to consider here. The first one is the fact that the greatest height above the plane is denoted by h. Now, we know that the greatest height can be found by the formula u sine theta squared over 2g. Okay, so this is a formula which you always need to know for maximum height. So in our particular case, they say the greatest height is denoted by h. So we have h being equal to, and in our particular case, it'll be u sine alpha, since alpha is the angle, squared, and that's over 2g. So that's essentially what we have. Now, this is going to be equal to, now u sine alpha. Now, we've been told that tan alpha is 2. So if I make a little right angle triangle here, okay, and I say this angle is alpha, okay, so we have this little triangle just to help us with the angles. Okay, so let me do this. All right, so since tan alpha is 2, it means that the opposite side is a 2 and this side is a 1. And by Pythagoras theorem, the third side is going to be a root 5. So basically, where we are saying u sine alpha, it will be, for sine alpha, that's 2 over root 5. So it's going to be 2 over root 5, and that's of u, and that's all squared. And it's over 2g, all right? And this is going to give us, if we simplify it a little bit more, we get 4 over 5 of u squared, and that's divided by 2g. So that's over 2g, which will give us, if we simplify it, okay, here 2 goes into 4 2 times. So that's 2u squared over 5g. So this is what we're having here for h. Now, they also tell us another statement. Here they say, when P is at a height of 3/4 h, it has traveled a horizontal distance of d. So for this, we're going to consider the equation of trajectory. Remember, y is equal to x tan. In this case, we're using alpha, but generally x tan theta minus gx squared over 2u squared of sec squared theta. So this is the equation of trajectory, all right? And for our particular case, for y, here they say the height is 3/4 of h, so that's going to be y. So we are using 3/4 of h being equal to x. Here they say the horizontal distance is d, so that's x. So basically that's going to be d of tan alpha. Tan is 2, all right? Tan alpha is 2, so this is going to be 2d. All right, and that's going to be minus gx squared. So that's d squared of g, basically, over 2u squared. So 2u squared, and that's of sec squared theta. Now I want to write sec squared theta as tan squared theta plus 1. Basically, we know that sec squared theta is the same as 1 plus tan squared theta. So in our case, for sec squared alpha, we're going to write that as 1 plus tan squared alpha. Remember, tan alpha is 2. So basically, that's 1 plus 2 squared that we'll be having. So let's simplify this, okay? What we got earlier, this one I'll call it 1, okay? So we are working on the other one right here. Let's carry on. Okay, so with what we have, I'm going to write it down here. It's going to be 3 quarters of h being equal to 2d minus, this is 5, right? So we have 5 of d squared g, and that's over 2u squared. And now, since early on we had gotten from equation 1, okay, this I'm going to call this equation 2. So if we take back equation 1, where from equation 1 we have h being equal to 2u squared over 5g, okay? So 1 goes h is equal to 2u squared over 5g. We can make u squared the subject, which will be 5gh over 2. So essentially, if we're going to substitute that, it's substitute equation 1 into equation 2, we'll be having 3 quarters of h being equal to 2d minus 5d squared g over 2. And for 1 over u squared, we will have that as 2 over 5gh. All right. So what's going to happen here is the 2 goes into the 2 once. Then for 5g, they will cancel. So once. So what's remaining is d squared over h right there. So it's 3 quarters of h is equal to 2d minus d squared over h. Okay. Let's multiply all the terms by h. So all the terms by h. And if we do, we'll be having 3 quarters of h squared being equal to 2dh minus, here they'll cancel, so that's d squared. I will again multiply both sides by 4. So by 4 for all the terms. And when we do, we'll be having, here that will be 3h squared is equal to 8dh minus 4d squared. So we can rearrange this to 4d squared, all right, minus 8dh plus 3h squared equal to 0. Now remember, what the question says is we should find the 2 possible values of d. So basically that's going to be, we can factorize this actually. And when we factorize, we will be having here for factors of 4d squared, that's 2d and 2d. And we will have 3h and h, then minus and minus. So we factorize this. So the possible values, we're going to say it's either 2d minus 3h is the one that's equal to 0, or 2d minus h is the one that's equal to 0. So here we get d being equal to 3 over 2 of h, and d being equal to h over 2. So since the question says we should find the actually the possible values of d, okay, it says we should find the 2 possible values of d. So these are the ones we've gotten. Okay, d is equal to 3 over 2 of h, and d is equal to h over 2. So that's the answer here. And that's how we do it.